let's start the next chapter. It's basically first order and higher degree. Okay, so I already discussed about degree and order. If there is any equation in the form of dy dx equals to f of xy in this form, then we can first order first degree because there is only one first order derivative involved in this equation, and also the index value of this highest order derivative is 1. So we call this differential equation is a first order first degree. But suppose there is a differential equation given which is first order but degree is not equals to 1. Okay, suppose for an example, um, let me take this equation. Suppose dy dx plus 1 by dy dx equals to c. Okay, so if we write this differential equation in this way, dy dx whole square plus 1 equals to c into dy dx. Okay, so we can say that order of this differential equation is 1 because there is first order derivative involved in this equation. But the index value of the highest order derivative is 2. The highest index value is 2. So it's very clear that this differential equation is of degree 2. Okay. So for this type of differential equation, how to find the general solution of this differential equation? So in this chapter, we will learn about this. Okay. So the first order and nth degree differential equation can be written in the form of P0 dy dx to the power n plus P1 dy dx to the power n minus 1 plus P2 dy dx to the power n minus 2 plus and so on plus Pn, okay, equals to 0. Here this P1, P2, Pn are function of x and y, or it may be constant also. And uh, we write this differential equation in this way: P0 uh, p to the power n plus P1 p to the power n minus 1 and so on. Okay, where this p is nothing but dy dx. Okay, so we use this notation that dy dx equals to p. If any differential equation can be written as a factor of p, in factorization we can factorize this equation 1. So then we use this method. It's known as solvable for t. Okay. So suppose the differential equation, the first equation, this equation. Okay. If we can write this in the form of this in factor, we can write this p minus f1 xy, p minus f2 xy, and so on, p minus fn xy equals to 0. Okay, if we can write this differential equation in this way, then we can use this method solvable for p. Otherwise, we have to apply the different method. Okay, so first we learn how to apply this method. Okay, so here we take each and every separate equation, means we take this as equation, first equation. So P is basically dy dx minus f1 xy, and the next equation in this way, and the last equation in this way. Means separately we solve each and every equation. Okay. So if you look that each and every equation here, it's first order first degree. Okay. And in previous videos, we explain how to solve first order first degree differential equation. Okay, so using those method, we solve each and every first order first degree differential equation. Suppose for the first one, we get the solution, general solution, this f1 xy c1. Okay, and for the suppose this one, for the second one, we get the solution, this f2 f of f2 of xy c2, and for the last one we get the solution f in xy cn equals to 0, where c1, c2 and cn are arbitrary constant. The general solution will be the product of this solution. So general solution will be this f1, f2 up to fn. We have to multiply the general solution of each and every uh, first order first degree differential equation. Okay, so here we consider C1, C2, C3, Cn equals to C, because the equation is basically first order. So the number of arbitrary constant is, it will be 1. So definitely we have to consider C1, C2, Cn as C. Okay, now try to apply this method in one particular example and try to find the solution of this differential. Here the differential equation given P2 minus P of e to the power x plus e to the power minus x plus 1 equals to 0. Okay, so try to let me explain how to solve this differential equation. So the given differential equation is p square minus p of e to the power x plus e to the power minus x plus 1 equals to 0. Okay, so we can write this given equation in the form of p square minus e to the power xp minus e to the power minus xp plus 1 equals to 0. Okay, so if we take p common from first two term, it will be p of p minus e to the power x minus, if we take e to the power minus x common, so the next term will be e to the power minus x of p minus e to the power x equals to 0. Okay, so therefore we can write this differential equation in the form of p minus e to the power x into p minus e to the power minus x. Here we write this differential equation as a product of these two first order first degree differential equation. So we have to solve each and every first order first degree differential equation separately. Okay, we have to solve this separately. So we know that p is nothing but dy dx. So if we write dy dx equals to e to the power x, and if we solve this differential equation, so we can write this in the form of dy equals to e to the power x dx, and if we integrate this equation both sides, it will be y equals to e to the power x plus c1. And in a similar way, the second first order first degree differential equation is p minus e to the power minus x equals to 0. Okay, so we can write this in the form of dy dx equals to e to the power minus x. Okay, so it is basically dy equals to e to the power minus x dx, and if we integrate this in both sides, it will be y equals to minus e to the power minus x plus c2. Okay, so therefore the general solution will be the product of this two. Okay, so we can write this solution in the form of y minus e to the power x minus c1. It's a first one, and the second one we can write in this way: y plus e to the power minus x minus c2 equals to 0. Here this c1 we have to take c1 equals to c2 equals to c. Okay, so the general solution will be y minus e to the power x minus c into y plus e to the power minus x minus c equals to 0. Here c being arbitrary constant. Okay, so in this way we solve any first order higher degree differential equation using the method of solvable for p. Okay, so remember one thing, we can apply this method when we can write the given differential equation as a product of two linear factors. Okay, otherwise we have to try another method. Pause this video and try to find the solution of this differential equation: x into y p to p square plus p of 3x square minus 2y square minus 6xy equals to 0. We can write the given differential equation in the form of xyp square plus 3px square minus 2py square minus 6xy equals to 0. And If we factorize this equation, we can write px minus 2y into py plus 3x equals to 0. Okay, so we have to solve this first order first degree differential equation separately. So the first equation is x into dy dx equals to 2y. Okay, using separation method, we can solve this differential equation. So this differential equation, the solution of the differential equation is this. Okay. Okay. And the second one is y into dy dx equals to minus 3x. So if we using the same separation method, um, we can write this equation in the form of y into dy equals to minus 3x dx. Okay. And if we integrate this, it will be y square uh, plus 3x square equals to c. Okay. So we can write this equation, the solution, in the form of y square plus 3x square minus c equals to 0. Okay, so therefore the general solution is the product of these two solution, y minus c x square into y square plus 3x square minus c equals to 0. Now again pause this video and try to find the general solution of this differential equation. So the given differential equation is xy into dy dx square minus 1 equals to x square minus y square dy dx. Okay, so we know that we can write this dy dx as p. So this value, it will be also p. Okay, so therefore the differential equation, it will be xy p square plus y square p minus x square p minus xy equals to 0. And if we factorize this, it will be xp plus yp minus x equals to 0. So it's very clear now. We have to solve this first order first degree differential equation separately. So the first differential equation is xp plus y equals to 0. So it will be basically this differential equation. And the second one is yp minus x equals to 0. So just using separation method, we can easily find the solution. So their solution is xy equals to 0, the first one, and the second one, it will be y square minus x square equals to c2. Okay, so we have to consider c1, c2 as c. So therefore the general solution of the given differential equation will be xy minus c into x square minus y square plus c equals to 0. Okay, this method is very easy. So now pause this video and try to find the solution of the last one. So here the given differential equation is dy dx minus dx dy equals to x by y minus y by x. So we can write this differential equation in the form of p minus 1 by p equals to x square minus y square divided by xy. Okay, and just simplifying this, try to write the given differential equation as a product of two linear um, equation. Okay, so it will be px plus y into py minus x. So separately solve this differential equation, px plus y equals to 0 and also py minus x equals to 0. Same way, using separation method, we solve this differential equation. Solve this differential equation. In first differential equation, the solution is xy equals to c1, and in second differential, the solution of the second one is y square minus x square equals to c2. So therefore the general solution, it will be xy minus c into y square minus x square minus c equals to 0. Okay, so I hope the method is clear and it's very easy to calculate. Now it's your job to find the solution of this 5 differential equation. So let me solve the problem number 5. So the solution of the problem number 5 is the given differential equation is p square plus 2xp minus 3x square equals to 0. Okay. So now this differential equation can be written as p square plus 3xp minus xp minus 3x square equals to 0. We can take p common, so it will be p plus 3x. Okay. And if we take x common, it will be p plus 3x. Okay. So therefore, we can write the given differential equation as a product of p plus 3x into p minus x equals to 0. So now in this method, we have to separately solve these two first order first degree differential equation. So therefore, the first one is p plus 3x equals to 0 and the second one is p minus x equals to 0. Okay. Here we can write p as dy dx equals to minus 3x, and using separation method it's very easy to understand that the solution will be y plus 3 by 2 x square minus c1 equals to 0, and the second one we can write in the form of this. So it will be y minus x square by 2 minus c2 equals to 0. So therefore, the general solution of the given differential equation will be y plus 3 by 2 x square minus c into y minus x square by 2 minus c equals to 0. So we consider c1, c2 equals to c. Okay, where c being an arbitrary constant. So in this way, try to find the solution of this four given differential equation. Okay.